Kuzambula. Welcome to Bhutan e-learning program. I'm Ugin Kyalzang from Gelifu Middle Secondary School. This lesson today is intended for Key Stage 4 learners for classes 9 to 10. And the topic for discussion today is equations of a linear graph. Let us take a look into the objectives for our lesson today. Firstly, we'll identify and graph a line represented in the slope and y-intercept form. We'll determine the slope and y-intercept form of an equation from a given linear graph. We'll identify and graph a line represented in the standard form. And finally, we'll determine the equation in slope and y-intercept form from a standard form. To begin with, let's look at the first form of equation that we have, that is slope and y-intercept form. The equation looks something like this. We have y equals to mx plus b. We have an isolated y term on the left hand side, and we have x term with the coefficient m and a constant value b. But what do these values mean? What are these variables? M represents the slope and b represents y-intercept. Well, some of you may already be having some idea about these words, but some may not. Let's look into it. Let's look into the slope represented by m first. So what is it? The generic meaning of the word slope is a measure of steepness of a line. In mathematics and in coordinate geometry, we think about it as a rate at which the y variable changes in terms of the change in x variable. And if I make it more concise, in mathematical fraction, we have slope equals to change in y variable divided by the change in x variable. Now, thinking about a line, and let's consider 2 points on a line. So if you take 2 points on the line and take the coordinates as x1, y1 and x2, y2, this definition of slope translates into a formula which says slope is equal to y2 minus y1 divided by x2 minus x1. That is the change in the y variable over change in the x variable. And the more generic and the more popular form of the formula is slope equals to rise, that is change in the y variable, over run, that is change in the x variable. Now, let's think about slope, the nature of slope and the value of slope. Do you think the slope will always be a positive value? Or maybe it can be a negative value, or sometimes it may just be zero. So let's think about these situations. So I have a set of 3 examples. In the first example, we are looking at a situation where when the x variable increases, the y variable also increases. So taking a look at this line, let us first of all identify 2 points. So the first point and the second point. So for the first point, let's take down its coordinate as x1, y1, and for the second point, we'll take its coordinates x2 and y2. And then we apply the formula, that is slope equals to y2 minus y1 over x2 minus x1. We take down the respective values from the graph and we calculate it. And in this case, that is when the x coordinate increases and the y coordinate increases simultaneously, we get a positive value of slope, and this represents a positive slope. In the second example, let's take a look at this line where when the x coordinate increases, the y coordinate decreases. Again, taking the 2 points, identifying its coordinates and applying the slope formula, here interestingly we get a slope as a negative value. So this is an example of a negative slope. The third example is quite interesting. When the value of x coordinate increases, there is no change in the y coordinate. Because of this, when you apply the formula and substitute the values of the coordinates, we get the slope equals to 0 because there is no change in y coordinate. There is no change in y-axis. So this is a unique example where the slope becomes 0. So after looking at the slopes, now let us take our attention to the next idea of intercepts. So what is an intercept? Let's try to understand the basic concept of intercept. It says the value of the y coordinate or the x-coordinate where the graph meets or crosses the axis. It could be the x-axis or the y-axis. So first, let's think about the x-intercept. So we can see the line which is cutting through both the axes, the x-axis and the y-axis, but which one represents x-intercept? It is this point where the value is x equals to -2. So the point where the line cuts the x-axis is the x-intercept. The second one, we have the y-intercepts. I have named it B. Why? Because this is the one which is used for our slope and y-intercept form. So in this case, which one is the y-intercept? Is it the point where the line cuts the x-axis or the y-axis? As you can guess it, it is the point where the line cuts the y-axis, and that is y equals to 4. So with a very basic understanding of what a slope is and what an y-intercept is, we can now put these ideas and combine it to get our slope and y-intercept form. So determining the equation of a line from a graph. Let's take a line from a graph, and then we start with the same process that we did earlier to find the slope. And the most important and the very first step that we do is identify 2 points on the line. After identifying the 2 points, we again identify its x-coordinate, y-coordinate respectively. We use these coordinates to find the slope. If you remember the formula, it's y2 minus y1 divided by x2 minus x1. So we find the slope. Okay, we have the slope. What do we do now? We go for the y-intercept. But do we have to calculate it? Looking at the graph, we don't, because we just identify it. How? As the point where the line cuts the, is it x-axis or y-axis? For the y-intercept, it is the y-axis. So this is the point, and we have the value y-intercept as 4. So we get our 2 very important values. The slope, which is represented by m, is the slope. We get it 2. And y-intercept represented by b, we get it 4. And the very simple thing to do now, substitute these 2 values back into the equation. And we are finally here with y equals to 2x plus 4. This is a very simple example of how a linear graph can be represented into an equational form. And this form is known as the slope and y-intercept form. Okay, so we have seen how we can extract a linear equation from a given graphical representation in the form of slope and y-intercept form. For our next activity, we have how to sketch a line from a linear equation that is in the slope and y-intercept form. So here we have our tasks. It says sketch a graph of a line represented by the equation y equals to -2/3 x minus 1. This is in the form of slope and y-intercept form. However, to go about this task, we have 2 ways to do so. The first is the traditional method of using a table of values and plotting the points in the coordinate grid. However, for our lesson today, I'll be showing you another very interesting method of doing the same task. This is by using the 2 main values given in the slope and y-intercept form. So here we will be using our slope and y-intercept. Just these 2 values, and we will be able to graph the linear graph. So how do we do that? Let us take a look back to our standard form of general form of slope and y-intercept form. We have y equals to mx plus b. Let us compare our general form with the equation at hand. It says y equals to -2/3x minus 1. So now, if we compare them, let us look at the x term and look at the coefficient of the x term here. So as the coefficient of x, we have -2/3, and this represents the slope of our equation of our linear graph. And as the y-intercept part, we have -1. So to separate the value of the y-intercept, we'll put an addition sign and extract the negative sign, put it with 1, and put it in the bracket. By doing this, we are not changing the value of the equation. So let's go about the graphing now. So here we have the y-intercept as value -1. This is our starting point. This is where we will start our graphing now. We will take this y-intercept, that is -1, and we will go to our graph and plot it on our graph. So this is the point. Now we have used the value of our y-intercept. Now let's go back to slope. For the slope, the value that we got from the equation is -2/3. Basically, this fraction represents the slope, which is the rise over run. So here, the rise, as you can see, is -2. So when we say rise as a -2, it is a negative rise. And while we consider of rise, we are thinking of the y-axis. So a -2 rise means, are we going up or are we going down? Because the value is negative, we are going down. So from our y-intercept point, we are going 2 units down. And then we reach here. Now, let us look at the value of our run. We have 3. So it's a +3 value here. And when we run along the x-axis. So 3, it's a +3. So we are taking 3 units, increasing value. So that is towards the right. So we take 3 units right to this point. So now, what we do now is basically we connect our first point to the final, to the point where we are at now. So the initial to the final point, we connect the 2 points, and here we have the linear graph. A very simple way to graph from a slope and y-intercept form. Let's take a look at the second form that we have in our hands, that is standard form. How does a standard form look like? The general form says it is ax plus by equals to c. So we have 2 terms on the left hand side, and it's an x term and it's a y term, and we have a constant value on the right hand side. The values a, b and c are values which can be represented by numbers, which are represented by numbers. They can be integers, they can be decimals, and they can be fractions also. Let's take an example here. We have 3x plus 2y equals to 6. When we go about standard form, one thing that we really need to understand is the concept of, again, the x-intercepts and the y-intercept. So this is the slide here, which you have already seen earlier. So it talks about the basic understanding of what is an x-intercept and what is a y-intercept. Now, let's try to explore this idea of x-intercept and y-intercept. Let's try to draw some more lines, random lines, and identify their x-intercepts. We notice here that when we identify these x-intercepts, the value of the x-coordinate changes, but the value of y-coordinate never changes. It always remains same for the x-intercepts. And what would that value be? So look at this and tell me what could be the value of y here. For all the x-intercepts, the value is always 0. The value of y is always 0 for all the x-intercepts. Now, trying to go to the y-intercepts, again, let us draw some random lines and try to point out the y-intercepts. So we have the y-intercepts here. Similarly, we notice that while the value of y-coordinate changes, the value of x-coordinate does not change. The x-coordinate always remains same for all the y-intercepts, and that is x is equal to 0. Now these ideas make sense because when we think of x-intercepts, we are talking about the points which are on the x-axis. So where the value of y will always be 0. And when we talk of y-intercepts, we are talking of all the points which are on the y-axis. where the value of x will always be 0. Now, with this understanding of x-intercepts and y-intercepts, let us now try to sketch a line from a linear equation which is now in the standard form. So we have a task here. It says, sketch a graph of a line represented by the equation 3x plus 2y equals to 6. Now this equation is in the form of standard form. So we begin by finding our x-intercept here. So how do we find the x-intercept? What is the unique characteristics or the unique condition for our x-intercept? It says no matter where the x-intercept are, the value of y is always 0. So we substitute the value y equals to 0 to find the x-intercept. So we take the equation 3x plus 2y equals to 6. However, we now replace the variable y with the value 0. So we have 3x equals to 6. However, we are not interested in the value of 3x. We need only the x. So how do we remove that 3 which is multiplied there? Yes, we divide it. But because it is an equation and we don't want to disturb the balance, we have to divide on both the sides. So divide by 3 on both the sides. So finally we get the value of x here. We get x equals to 2. And therefore the x-intercept point that we have is x is 2 and y is always 0. Now going to the next, we have finding y-intercept. Okay, we have the x-intercept, but now we need the y-intercept here. So how do we find the y-intercept? We substitute x equals to 0. So similarly, we take the equation and here now, instead of substituting y, we substitute the value of x with 0. And again, we come to the value 2y equals to 6. We don't want 2y, we just want y, so we divide both the sides by 2. And now we have y equals to 3. So for the y-intercept here, the value of y is 3. What could be the value of x? For all y-intercepts, the value of x will always be 0. So we have 0, 3. Okay, so we have our 2 points. They are our x-intercept and y-intercept, that is 2, 0 and 0, 3. We go to our graph, find the x-intercept, 2, 0, find the y-intercept, 0, 3, and connect the two lines. And here we have the graph of the linear equation, which was in the form of standard form. Now finally, this is the last activity that we have here before I give you the task, of course. What we are going to do finally is we have talked about slope and y-intercept form. We have also talked about standard form. Here what we are going to do is we are going to extract, or we are going to determine the slope and y-intercept form of a line if the equation is given in the standard form. So basically we are trying to convert a standard form of equation into a slope and y-intercept form. So this is an example that we have. Example of the standard form. We have 4x plus 5y equals to 20. On the left hand side we have 4x plus 5y. On the right hand side we have 20. Now this may feel uneasy to really accept that these two sides are equal, but because they are in the equation form and the equal sign in between tells that they are perfectly balanced. So 4x plus 5y, whatever that means, is exactly equal to 20. Now, what is our objective here? To take this equation and make it into slope and y-intercept form. How? But what is that form? That is, we have y equals to mx plus b. Now, the critical thing here to remember is, if you look on the left hand side of the slope and y-intercept form, the left hand side is, we have an isolated variable y. So this is our task at our hand. We have to make sure that this equation, whatever is given, we have to make sure that all the other terms and values and variables are sent to the right hand side. Okay, now let's begin. So we have 4x plus 5y equals to 20. We have to send someone from left hand side to right hand side. Whom do we send first? Yes, the item which is not connected to the variable y. We send 4x. But here 4x is added. So how can we remove it? Yes. How can we remove it? Of course, by subtracting 4x. But should I subtract on the left hand side or right hand side? The answer is we have to subtract on both the sides because we do not want to disturb the balance. They are perfectly balanced and they are perfectly equal. So we subtract minus 4x on both the sides. 4x is gone, but we are now left with 5y equals to 20 and minus 4x. We are getting closer, but still on the left hand side the y is not isolated. We still have 5y and we have to isolate y. So we take off that 5 which is multiplied. Now how do we take off 5 which is multiplied there? What do? We divide. Again we divide on both the sides to make sure that the balance is not disturbed. So we end up with this y equals to 20 minus 4x within bracket divided by 5. Because when you divide, we don't divide individually, we divide it together. Now it's time to divide them individually. So 5 goes inside the bracket on the right hand side. It goes to 20, it divides it, it goes to 4x and it divides it. But we cannot divide the 4x. So only we have, it divides 20 over 5, we get 4. So we are here with y equals to 4 minus 4x over 5. Do you think we are there yet? Do you think it's exactly looking the same? Let us check. On the left hand side we have y. Okay, we have y on our equation. However, the first term on the slope and y-intercept is the x term, which is not there in our case. So we just have to move the terms, just rearrange the terms. So the second term in our equation, minus 4x over 5 comes in the front, and the item in the front, that is positive 4, goes back. So we have this. So we have y equals to negative 4 over 5x plus 4. So this is how we go from a standard form of equation to slope and y-intercept form. Finally, I have a set of tasks for you. Look at the equations below. And the first task is to identify which equation is in the slope and y-intercept form and which equation is in the standard form. After identifying the two equations, you have to graph them. And finally, you determine the equation in the slope and y-intercept form from the standard form that you identified. So for this task, you have to use all the skills, all the ideas that we learned through this lesson. So that's all for the lesson today. Thank you for your attention. Hope you enjoyed the lesson, and I look forward to seeing you in the future lessons. Take care, keep exploring and keep learning. Thank you.